Hello and welcome to another discussion of Holt Winters' forecasting method. In the previous series of videos, I introduced you to Holt Winters, which is a great forecasting technique when data exhibits trend and or seasonality. So in the previous videos, I showed you how we can implement Holt Winters' forecasting method with at least 2 years worth of data. And recall that we need at least 2 years because the first year we use to seed the seasonal factors. And remember, the way we do this is we take an actual demand observation and subtract from it the average demand observation over the first year worth of data. So once we have seeded the seasonal factors, we then proceed to decompose actual demand into base level, trend, and seasonal components. And remember, the way we do that is we first seed the base level estimate in the last time period of the first year of observations. So in our case, we're looking here at December 2008. And we simply do that by taking the actual demand observation, so that would be 53,263, and subtracting from it the associated seasonal factor. Likewise, we see the trend component, typically using 0. And we have the seasonal factor, of course, calculated as I just mentioned. And then we use that information to continue and to use the second year worth of data to decompose actual demand observations into the 3 components based on trend and seasonal factor. Now recall, just to remind you again how we do that, is we use weighting components, alpha, beta, and gamma, respectively, to calculate weighted averages for these 3 components. So we're looking at the base level, for example, use weighting factor alpha, and then we basically apply that weighting factor to 2 different ways of estimating a base level. The first way is to take the actual demand observation of that period and subtract from it the seasonal factor that corresponds to this time period 1 year earlier. So in other words, we took a demand of 55,735 and subtracted from it the seasonal factor from January of 2009. $9,286, negative 9,286, that is. And then we added 1 minus alpha. That's the other weighting component, and that consists of the base level from the previous period augmented by the previous trend estimate. So you see, this is our weighted average estimate of the base level. Likewise, we implement similar approaches for trend and seasonal factor. For trend, we use beta as a weighting factor, and then we estimate trend again in one of 2 ways. First, we take the current base level estimate and subtract from that the previous base level estimate. Or of course, we weight by 1 minus beta, the prior period trend component. And finally, we did a similar thing for the seasonal factor. Here the weighting factor is gamma, and we weight gamma, the first estimate. We apply this weight to the first estimate of the seasonal factor, and that simply is taking the actual demand observation and subtracting from it the corresponding base level estimate. Or of course, another way of estimating seasonality would be applying the weighting factor 1 minus gamma and using the prior year seasonal factor. So far I'm not telling you anything new. This is what we've done previously. Now what we did do in the prior video, if you recall, is we calculated in-sample forecast. And the way we calculated in-sample forecast is we added up base level, trend, and seasonal factors to come up with a forecast. And then we proceeded to calculate forecast errors and so forth. Now I also showed you how you can then use this forecast and associated forecast error information to find the values of alpha, beta, and gamma that minimize forecast errors. Now I'm not going to do this here. Now remember, I told you one thing in those preceding videos, and that was there's a little bit of a problem with doing that. And that's because these forecasts here are hypothetical or theoretical forecasts, in the sense that they clearly incorporate current period demand observation information. So they are not really real. They're not true forecasts. And if we fit the values of alpha, beta, and gamma to these somewhat abstract forecasts, we actually run the risk of fitting alpha, beta, and gamma to something other than systematic forecasts and other than systematic forecast errors. So it's a little bit of an artificial exercise, if you will, that might cause us to fit alpha, beta, and gamma to random variability rather than to structured forecasts and associated forecast level. So in this video, I want to show you something else that we can do if we have more than 2 years worth of data. So I'll get rid of these in-sample forecasts, and as it turns out in this example here, we have more than 2 years worth of data. and I've color-coded those. In fact, we have a little more than 3 years worth of data. We have 2 years, as we just discussed, and then we have demand data continuing all the way through February of 2013. Now what I want to do now is show you how we can use this kind of data to actually do a better job implementing Holt Winters forecasting method. And specifically, what we're going to do is we're going to calculate forecasts the way we do if we didn't have actual demand information. In other words, let's take a look at January 2011. So let's put ourselves back in time to December 2010 and ask ourselves, how would we implement or how would we forecast demand for January 2011 if we didn't actually have demand information for 2011? Well, of course, the answer is, well, the forecast would be equal to the most recent base level estimate plus the most recent trend estimate plus the most recent relevant seasonal factor estimate. In our case, negative 6,405. So this is a forecast that is truly an out-of-sample forecast in the sense that if I am in December 2010, this is my best way of predicting what future demand will be in the next month in January 2011. So this is a more meaningful forecast than those in sample forecasts that we have previously discussed. Now, of course, what I can do again is I can calculate forecast errors, so actual demand minus the forecast, and I will look at the absolute value of that as well. And remember, I need that to calculate certain forecast error statistics. So likewise, of course, I can now continue to break down actual demand observations into base level, trend, and seasonal factors. In other words, so let's say we roll into January 2011, and at that point we will be concerned with forecasting demand for February 2011. And of course, the way we should do that again is we should use the most recent base level estimate and the most recent trend level estimate and the most recent relevant seasonal factor estimate to forecast demand for 2011. In other words, what we're going to do is simply copy all this information through the remainder of our data set. Again, the key difference here is that these forecasts are generated using information from preceding periods only, not incorporating the actual demand observation of the current period. In other words, they are what forecasts would have been if we had generated them ahead of time. So accordingly, these forecast errors here are really more meaningful because these are probably the forecast errors we would have truly encountered had we had to forecast demand for January 2011 and onwards. Now, what I can do then, of course, is I can go ahead and calculate my forecast error statistics. So when we do that, we need to get the mean absolute deviation, of course, would be the average of all absolute forecast errors, in this case 3,354 roughly. Likewise, the mean error is going to be the average of all nominal factor errors. In this case, we're getting negative 928. We can also look at the mean absolute percentage error if you wanted to. I'm going to skip this one for now, but I will take a look at the standard deviation of forecast errors. So standard deviation of nominal forecast error gives me 3,874 roughly. Now what I can do then, of course, and I will show you that in a moment, I can find those values of alpha, beta, and gamma that would minimize forecast errors. Before we do that, though, I just want to do one more thing, and that is actually calculate, of course, true out-of-sample forecasts. So notice that I have to mandate up until and including February 2012, but that's the end of the line. So I can then calculate my out-of-sample forecast as the most recent base level estimate plus the most recent trend estimate plus the most recent relevant seasonal factor estimate, which would be that of March 2012. So you see I get 96,059. I'm going to copy this formula down, but remember one important thing. See, actually a few important things. First of all, we need to lock in the reference of the base level. We need to lock in the reference of the trend level as well. But in addition, we need to make sure we add the proper number of trend components. So that will be 2 times for April 2013 and 3 times for May 2013. So you see here with the given values of alpha, beta, and gamma, I would get forecast values of 96,059, 101,425, and 99,213 for March, April, and May of 2013 respectively. Now let's go ahead and calculate the reorder point here for a normal distribution assumption and a 96% level. So I'll calculate the safety stock requirement here as a norms inverse of 96%, and I will simply multiply that by the standard deviation for forecast errors. So I get about 6,782, and that gives me a reorder point for March 2012. That is equal to the sum of the associated forecast and the safety stock we just calculated. So 102,841. Now let me copy these numbers and paste them as values to make sure they won't change. And now we'll do that. And now we'll do what I had mentioned earlier. We're going to ask Solver to find values of alpha, beta, and gamma that will minimize the standard deviation of forecast errors. Of course, subject to the usual constraints, that is, that of alpha, beta, and gamma should fall within pre-specified ranges. Now I click on Solve and see what I find is that alpha should be ideally about 0.24, beta about 0.176, which is its maximum value, and gamma 0.5, again reaching its maximum value. Once we do that, notice how, of course, the forecasts change. So again, I'm going to go ahead and copy those over here, and accordingly our safety stocks and reorder point will change as well. Notice now that the standard deviation of forecast errors has changed, as well as after optimization. We're going to be looking at norms inverse times the new standard deviation of forecast errors. And you see, of course, I need less safety stock because I've managed to reduce uncertainty by fitting alpha, beta, and gamma. And as a result, my reorder point will change as well. So that will be the sum of the associated forecast and the new lower safety stock. So this really is the best way probably of implementing Holt Winters. The key idea being I will evaluate forecast errors only when I have enough data to actually develop forecasts using only prior period demand information, as opposed to including same period demand information. But that only works if you have at least 3 years worth of data. As always, if you have any questions about Holt Winters, above and beyond what we have just discussed, feel free to reach out to me. And thank you for watching.